In this video, we're going to start to do some binary math. We're going to keep it all to 1-byte operations to keep it simple. This is an introductory course after all. But we're going to do addition, and then we're going to see what it takes to do subtraction. But that's for a later video. So for right now, we're going to start with binary addition. Okay, let's look at it and jump right in. In binary, like we've been saying, we're dealing with switches on or switches off. So we're representing the switch on as a 1, off as a 0. So binary is basically base 2 math of a 0 or a 1. Those are the only two digits we have in binary math. So when we add, if we get a value of 2, what it really is a 0 remainder, and we carry that power of 2 to the next bit position. Okay? So if we're adding, the first position is a 1, and we're adding 2 of those 1s together, we're going to get a 0 and have to carry the bit forward. All right? So 0 plus 0 should be fairly simple for high school students, right? 0 plus 1 should also not be really challenging, since we're going to be dealing with two different registers that we're adding together, if you will. We might see it the other way around. Ooh, right? But when we get a 1 plus 1, we have to understand that it's a 0 remainder and a single carry to the next place. Because we're not going to carry a 2, we're going to carry a 1, because it's 1 power of 2 that we're carrying. This is where a lot of students get confused, especially early on in computer science, because in base 10 you're carrying a 1. Well, it's easy to think 1 because that's a power of 10. But in base 2, when we carry 1, we're carrying 1 power of 2. It's still a 1 that we carry. All right, so let's do some examples. And again, these are pretty simple. 0 and 1 is 1. 1 and 0 is 1. And if we get to a 1 plus a 1, in binary, that's a 0, and we carry the power of 2 to the next bit position. Okay? And bit position is important, and we'll talk about that in a minute, but then that becomes 1, 0. So now you should understand the joke on the t-shirts, right? There are 1, 0 types of people in the world is a lot different than there are 10 types of people in the world, those who read binary and those who don't. 1, 0 in binary is, this is 2 to the 0, and this is 2 to the 1, so that's 2. So in decimal, 1, 0 is 2. So for nerds, the t-shirt says there's 2 types of people in the world. They're just reading it in binary. Okay? Let's do a little harder one. 1, 1 plus 1, 1. Now we're not saying 11 plus 11 equals 110. Okay? We're saying 1, 1 binary, which is 3, plus 3 should come out to 6. Okay? So 1 plus 1 is 0, carry the 1. Well, now we get a 3, a 1, a 1, and a 1, because we carried 1 in. So what do we do now? Well, that's a 1 is a remainder, and we still carry the power of 2, which then comes down to give us 1, 1, 0. And 1, 1, 0 in binary is 2 to the 0, 2 to the 1, 2 squared. So that's 4 plus 2 is 6. And 3 and 3 does it actually equal 6, so we know we're right on that one. Okay? Now, when you do this, it's a lot easier if you just write the decimal positions, if you will, for the bits of a byte. So 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, etc., all the way through 128. So the first bit is the position for 1, and the last bit is the position for 128. So if we were to have all 1s, if you add up all those numbers, you get 255. Okay? Now 2 to the 8th is 256. So why, if I add them all up, does it add up to 255? Because 0 is one of those combinations. 2 to the 8th means we have 256 combinations of 1s and 0s. Well, 0 is one of those. 0 gets a vote, so to speak. So 0 is one of them. All of them lit is 255. So the values I can store on 1 byte is from 0 to 255, inclusive. Okay? All right. So let's do a little bit harder binary math, okay? So what are these? Well, that's 8 and 4. So that should be 12 plus 12, and we should get 24. Now we know that 16 and 8 is 24, or at least we should. So we should see a result where this one and this one are set. All right, but let's see what we get. And by the way, that's one of the nice things about being a teacher. I get to pick the math up front, make sure that I can do it. See? Okay, here we go. 12, look at that, it's a 12. And that's a 12, okay? So here we go. 0 plus 0, that one's a no-brainer. That one's a no-brainer. Now 1 plus 1 is 2, so that's a 0 with a carry. And now we get that 3, okay, which is a 1 and carry another one, right? So that's 3, so that's a remainder of 1 and carry 1. And now that's going to come down, and the other 3 just drop down, and we do get 24, 16 and A is 24. We know we said it right. Okay? Easy. Let's do another one. All right, there's our binary number line, if you will. We're going to do those two numbers. Now, those are pretty big numbers. I'm going to tell you up front that that first one's 95, and the second one is 158. Because I want you to understand that it's really just not that hard. Okay? In some ways, it's almost easier if you're just dealing with the byte values. Okay? For the binary. So let's start. So 1 and 0 is 1. 1 and 1 is 2, so that's a 0. And we have a carry. That's a 3, so that's a 1 remainder with a carry. There it is again. 1 remainder with a carry. 1 remainder with a carry. That one just comes down. And the last two just come down. And we get 253. And 253, we can tell quickly that that's correct, because we know if all of them are set, we get 255. And look at that, the 2-bit is not set. So 255 minus 2 is 253. Okay? So that's math in binary. It's really not that hard. If we had a bigger number, we would just keep going into the next register. As long as, like we've talked about, we have enough registers to keep going into. Because the system would then know, okay, the next one's going to be the 256-bit, then the 512-bit, and it's going to keep going. Because as we string these bytes together, we consider them higher powers of 2 for the purposes of doing bigger numbers. Okay? Now, in the next video, we're going to begin to look at what we need to do for subtraction. Okay? But for now, I'll see you on the other side.